Okay, looks like we have sound. Let's see where we left off. Um, oh, I think we finished 91. So some more transformations. Um, Actually, since the graph is given, it'd be good to copy it. Now, we're told for the following exercise, use that graph to transform each of the following. Okay, so 92, g of x equals f of x plus 1. Well, that's fine. It's just this is raised up 1 unit, so that that would be there, 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 and that would be there. So that one is y equals g92 of x. Then 93, g of x equals f of x minus 1 plus 2. So that's 1 to the right and 2 up. That's that one. That one there, 1 to the right and 2 up. 1 to the right and 2 up. One to the right and 2 up. 1 to the right and 2 up. 1 to the right and 2 up. Okay. Okay. Got the answers here. Let's have a look. 93. Oh, interesting. They don't extend the graph. That's interesting. Yeah, okay. Oh, I suppose not actually, because the graph doesn't actually go under the x-axis, so see when I have the printed, yeah, okay. I'll just clean that, I'll fix that now. Let's see now. It's that's definitely gone. And the red one. The red one doesn't actually quite go there, it's just the blue one. Okay. And then that's gone there. So that's okay, and then the red one. So there's nothing there. Yeah. Yeah. That's better, I think. Yeah. Okay, so that's 92 and 93. Okay. For the following exercises for each of the piecewise defined functions, A, evaluate at the given values of the independent variable, and B, sketch the graph. Okay, so I'm going to need to make some space here. Okay. So let's make our graph first. Y, X. Okay, so 94, we have fx equals 4x plus 3, x is less than or equal to 0, and minus x plus 1, when x is more than 0. and we want to calculate f of minus 3. So that would be when x is negative. So that's 4 times minus 3 plus 3. That's minus 12 plus 3, which is minus 9. F of 0 would be 4 times 0 plus 3, which is 3. And then f of 2 would be minus 2 plus 1, which is minus 1. So I'll just mark off 0 here, and I'll go minus 1, minus 2, 1, 2, and then we'll go 1, 2, 3, 4, 1, 2, 3, 4. Should keep it on the right, so since I started on the right up there. So when it's negative, is 4x plus 3. Well, I know it's going to cross the y-axis at 3. And actually, I'll use that point there. Minus 3 is, it's way too small. So I'll just use minus 1. 4 times minus 1 is minus 4, plus 3 is minus 1. So, yeah, okay. So it's a line like that. Then, when we have positive, so it's open, oops, it's open here. You don't actually get the 1. And then see, when when it's 2, we get minus 1. So the graph will look like this then. Yeah, okay. So that's, I think that's okay. That's 94. It's rising, and then it's falling. Yeah. Okay. Yeah, okay, I think that's fine. Okay, let's have a look at the next one. $95. We have, oh, beep. Okay. At 95, we've got f of x equals x squared minus 3 when x is positive, and 4x minus 3. Sorry, when it's negative, why I say positive? And then 4x minus 3 when x is greater than or equal to 0. So f of minus 4, that's definitely the negative. That'll be 16 minus 3, which is 13. F of 0, that's the second one. It's going to be minus 3. And then f of 2 is the second one again. It's 8 minus 3, which is 5. So let's see now. We'll go minus 1, minus 2, minus 3, 1, 2, 3. And we'll go 1, 2, 3, 4, like that. 1, 2, 3, 4, like that. Right. So negative, it's a quadratic. At 0, you get don't actually get minus 3, because you don't actually reach the 0. At minus 1, you'll get minus 2. Okay, so maybe that scale's a bit too small. 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. Okay. At 0, we'll get minus 3, but not quite actually. And then at minus 1, we'll get minus 2. Then at minus 2, we'll get 1. Then at -3, we'll get 6. So that'll be like way up there. And then now let's have a look at the positive. So, oh, so we actually do get -3 by virtue of the second one. So actually, I might want to just fix that up there. So we do get a continuity here. Because when x is 0, we get -3. When x is 1, we get 1. When x is 2, we get 5. So that would be up here. So I'm going to get a straight line like this. Okay, so it's a bit wobbly looking, isn't it? No, I'm having trouble sketching quadratics today. It curves. I think the problem is I didn't quite have enough of a curve at the beginning. It's messing me up. And oh man, this is worse. I can't sketch a quadratic right now. Curved on the left and straight on the right. Let's see how it looks in the book. Yeah, well, okay. It's not the best, but it's not the worst. Okay, so that's fine. That's 95. Now let's have a look at 96. 96. Oh, good. That's going to be easier to sketch. H of x equals x plus 1 when x is less than or equal to 5, and 4 when x is more than 5. So h of 0, well, that's less than or equal to 5, so that's going to be 1. H of pi, that's also less than or equal to 5, so that's pi plus 1. Then h of 4, 4 is also less than or equal to 5, so 4 plus 1 is 5. What a weird choice of numbers. Less than or equal to 5. Oh, I'm sorry, I wrote the last one down wrong. Why did I? The last one was 0 pi, so that's a 5, sorry. So that's a 4. H is 0, pi, and 5. And the first two are less than or equal to 5, so it'll be 1 and pi plus 1, and then 4. Is it? No, it's not 4, because h of 5 is still less than or equal to 5. So h of 5 will be 6 then. So I think 1, 2, 3, 4, 5, 6, minus 1, minus 2, minus 3, minus 4, etc. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, etc. You get the idea. So when it's less than or equal to 5, so for example, when x is 0, we get 1. When x is 1, we get 2. When x is 2, we get 3. And then when x is 5, we get 6. Then when x is more than 5, we get 4. So you don't actually get the 4 here when x is 5. So that's kind of open there, and that one's closed. My little dots make it look a little bit more confusing, doesn't it? Yeah, and then that's horizontal, constant 4. So it looks like that. Yeah, okay. So 1 is 2, pi is pi plus 1, and 5 is 6. Okay, okay. And then 97. Still recording? Yep, 97. So you have g of x equals 3 over x minus 2 when x is not 2, and then 4 when x is 2. So g of 0 would be minus 3 over 2. G of minus 4 will be 3 over minus 6. That's minus a half. And then, naturally enough, g of 2, which would be 4 then. Okay, so let's go like 1, 2, 3. 1, 2, 3. Minus 1, minus 2, minus 3. Minus 1, minus 2, minus 3. Now, there's what's called a singularity, or is it a pole, at 2. So I'll just put a dotted line here. So when x is 0, we got 4, for example. And then I'll just put a dot there, and then minus, no, not 4, sorry. Minus 3 over 2. So that's like there. And then when we were at minus 4, we got minus a half. So it'd be like about here. So I think they're trying to help us see that this side of the graph, oh, it's an asymptote. That's what that line is called. Sorry. That they're trying to help us out with the shape. It's going to go straight down here. And then on the other side, it's like a mirror through it. So like, for example, at 3, we get 3 over, we just get 3. And then at 4, we get 3 over 1.5. So that'd be like here. So then it comes down the other side. And yeah. You know, I think what might be good actually is to draw the horizontal asymptote before I begin as well. So if you just change the g of x, or if you just look at the g of x when it goes to infinity, so that would be 3 over infinity. So like it'll be going towards 0 as x goes to infinity. And likewise, g of x will go to 0 as well when x goes to minus infinity. So the axis here is an asymptote that is not reached as well. Okay, so now I just put the points back in. So 0 is like here, and then minus 4 was like here, and it's coming from that horizontal asymptote and then down it goes. And then what did we say 3 was? Is 3. So then it's coming away like this here. Shoots up there. And then when x is 2, we have 4. So I should mark in here. 4. So when x is 2, we have 4. Okay. Okay. 97. So that actually should be in the solutions here. Yeah. And you know, I think I skipped some question. I think I skipped something. Oh no, I didn't skip anything. No, I got it all done. Let's just check the values here. -3/2, -1/2, and 4. I never checked the 95's values if I got them right. I must have, anyways. Okay, I think that'd be a good place to wrap it up then. Because then we're on to the true-false questions next, and then already onto the algebra, the software questions. Yeah, okay, so I think we're okay with that one. -3/2, -1/2, and 4. And I have the graph on the next page. Yeah. 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 Okay. Okay. All good. Let's wrap it up there.